Your Ansible playbook fails with resource deployment failure after 10 minutes. The container starts, then crashes. No logs, no clues. What broke? The ACI was under-provisioned. 1.5 GB memory for an app that needs 2 GB. The container OOM-killed itself silently. Let's break down Ansible Azure Automation, how it works, and the exact mistake behind that failure. Ansible Azure Automation lets you define your desired Azure infrastructure in YAML. Ansible compares the current state against the desired state and only makes API calls when changes are needed. This idempotency is key for production reliability. Before Ansible, Azure Automation meant ARM templates or Bash scripts. ARM templates lack idempotency checks, and CLI scripts leave resources in inconsistent states. Ansible's Azure RM modules solve this by checking current state before making changes. Here's a production playbook to ensure a VM exists. It uses the Azure RM virtual machine module with desired state parameters. If the VM already matches, no API call is made. The register keyword captures the result for debugging. This playbook creates or updates a VM. Note the state. Present ensures idempotency. The debug task shows whether the VM was created or already existed, but running this on 50 VMs in a loop will hit Azure's API rate limit. Authentication is the most common failure point. Service principal secrets expire, and token caching can cause silent failures. Managed identities auto-rotate credentials and eliminate secret management. For external runners, use certificate-based auth. With managed identity, you don't need to provide cliented, secret, or tenant. The module automatically uses the managed identity of the Azure VM or Azure DevOps agent. This is the most secure and reliable authentication method. Idempotency comes at a cost. Each module makes a GET request to check current state before making changes. At scale, this burns through API rate limits. Use Azure RM resource facts to fetch all resources in one call, then compare locally. To update only the VM size without triggering a reboot, use Azure RM resource with patch method. First, get current state with Azure RM resource facts, then conditionally apply the patch. This avoids the full put that can reboot the VM. Azure APIs throttle and occasionally return 5xx errors. Ansible's default is to fail immediately, but in production you need retries with exponential backoff. Use the until loop with retries and delay, but be careful. Set failed when, false to prevent premature failure. This pattern retries on 429 and 5xx errors with exponential backoff. The until condition checks for success or non-retrievable status codes. The failed when, false prevents the task from failing before the loop completes. After retries, we explicitly fail if still unsuccessful. Running Ansible against 500 Azure resources sequentially takes hours, but all in parallel will hit rate limits. Use throttle on individual tasks to limit concurrency. For bulk operations, use Azure RM deployment with an ARM template. A single API call creates multiple resources. This playbook deploys 10 VMs with a single ARM template deployment. The template uses copy index to create multiple resources. This is much faster and respects API rate limits better than looping over individual modules. Running Ansible from Azure DevOps requires careful secret management. Use managed identity on the agent, fetch secrets from Azure Key Vault at runtime, and use dynamic inventory scoped to specific resource groups to avoid exposing unintended resources. This Azure DevOps pipeline installs Ansible and runs a playbook. Note the environment variables for authentication. In production, use Azure Key Vault to fetch secrets instead of storing them in pipeline variables. This is the same issue we highlighted at the start. Here's exactly why that 3-hour outage happened. The Azure Software Development Kit caches tokens for 30 seconds by default. The playbook had multiple tasks, and the total time between the first and second task exceeded 30 seconds. The second task used an expired token, causing authorization failed. The error was silent because the playbook didn't check for it properly. The Azure Software Development Kit caches tokens for 30 seconds by default, causing token expiry during long playbooks. This led to silent authentication failures and the production incident. The fix was simple. Set the environment variable Azure token cache expiration seconds equals 300 before running Ansible. This extends the token cache lifetime to 5 minutes, preventing expiry during typical playbook runs. We also added retry logic to handle any remaining auth errors gracefully. The Azure Software Development Kit caches tokens for only 30 seconds by default. If your playbook takes longer between tasks, the token expires mid-playbook, causing authorization failed errors. Set Azure token cache expiration seconds equals 300 to extend the cache. The default token cache TTL is 30 seconds, which is too short for multitask playbooks. Always set Azure token cache expiration seconds to at least 300 to avoid silent auth failures. If you loop over 50 VMs without throttling, you'll hit Azure's 12,000 reads per hour limit within minutes. Use throttle or serial to control concurrency, or better, use Azure RM deployment with an ARM template for bulk operations. Using Azure RM Virtual Machine to change VM size calls Creator Update, PUT, which replaces the entire VM configuration and can trigger a reboot. Always use Azure RM Resource with patch for partial updates. The article uses Azure RM modules from the Azure AzCollection collection. In version 2+, some modules, e.g., Azure RM Virtual Machine, changed parameter names like SSH password enabled to SSH password enabled, still valid, but deprecated image in favor of image offer, image publisher, etc. Always pin the collection version in requirements, IML to avoid breaking changes. The article mentions using Azure RM Resource Facts to reduce GET calls, but doesn't show it. Here's how to fetch all VMs in a resource group with one API call and then iterate locally. Azure resource creation, e.g., VMs, can take minutes. The article mentions Async but doesn't warn that poll. 0 with Async status can cause race conditions if subsequent tasks depend on the resource. Always use poll 60 or higher for critical resources or add explicit wait tasks. When things go wrong, start with these commands. Check service principal roles with as role assignment list. Monitor rate limits with as monitor metrics. Verify resources with as resource show. And use Ansible's VVV flag to see detailed output, including waiting states. Let's run through some common interview questions. How does Ansible handle idempotency for Azure resources? It calls GET before PUT, incurring API cost. Use Azure RM Resource Facts to batch. When to choose Ansible over Terraform? Ansible for config management, Terraform for provisioning. Use both together. What happens when token expires mid-playbook? Authorization failed. Set Azure token cache expiration seconds equals 300. And a few frequently asked questions. How does Ansible authenticate to Azure? Via service principal and VARs or managed identity. What modules does Azure AzCollection provide? 200+ modules for compute, networking, storage, databases, PaaS. Can Ansible and Terraform manage the same resources? Yes, but use tags to coordinate. Terraform for infra, Ansible for config. Let's recap the key takeaways. Use managed identity for auth. Set token cache TTL to 300 seconds. Batch API calls with ARM templates. Add retry logic with exponential backoff. Ready to go deeper? Up next, building custom Ansible collections, then configuration drift and compliance, and Ansible for Kubernetes. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.